Welcome dear students to another session on data structures. In this video we are going to discuss about quicksort. So initially what is quicksort is? It is a divide and conquer algorithm for performing sorting. Now what divide and conquer means that you are dividing your entire unsorted array into sub-arrays and you are solving them recursively to get your solution. Now the steps for quicksort algorithm includes, first of all, we are going to pick up element known as pivot element. Now, after every iteration, your pivot element will be kept in the proper index at which it should be present after the sorting is completed. So, that is done by the partitioning algorithm, which is the second step. Now, this pivot element which we have discussed can be any element from the array. It can be first element or last element or the middle element. Now, after the partitioning is completed, the pivot element will be in its final position. Now, this is known as a partition operation, and we will be recursively applying the above steps to the sub-array elements, that is to the left of the pivot element and to the right of the pivot element. Now, the one thing which we have to notice, to the left side of every pivot element, only the elements which are smaller than the pivot element will be present, and towards the right side you will find all the elements that are greater to our pivot element. Now moving on, so this is the algorithm to apply quicksort. So initially we will be passing this proper array from starting from index 0 to last element to the quicksort algorithm, and here we will be identifying the index for our pivot element, and that index will be stored in mid by application of the partition algorithm. So once you have identified the value for mid, that means you have identified the proper index of the pivot element. Now you need to apply quicksort to the left part as well as to the right part. So firstly we will apply quicksort, and again it will recursively call this partition algorithm towards all elements on the left side, and after left side sorting is completed, we will move back to the right side of the pivot element's mid value, and after that we will apply sorting on the right side. Moving on, our partition algorithm, it actually keeps track of two indexes I and j so that we can traverse through our array. Now the I index will be incrementing starting from the starting of the array, and j index will be decrementing starting from the last element in the array. So we will be keep on moving through the array, incrementing I and decrementing j. So if at any case there are different cases in which this I and j stop incrementing. So if when they stop incrementing or decrementing, if the condition I less than j is true, then we can directly swap between I and j. If we have stopped incrementing I and stopped decrementing j at a condition and see that this is false, you can understand that you have got the correct position where your pivot element has to be placed. That is, in the sorted list where your pivot has to be placed, that is identified. If you have met this condition, that is I less than j is false, that means your pivot has to be placed at that value where j is currently, right? So we will quickly move on to an example where you will understand what this I and j increment and decrement means. So starting with the example. This is my unsorted array which has 5 elements: 25, 67, 23, 88 and 11. So what my quicksort says is identify the mid value for a pivot element. So first I want to recognize a pivot element, then a mid value where that pivot element will be ultimately placed. So I am assuming that my every first element will be my pivot element. So in iteration 1, my element at the index number 0 will be my pivot element, that is 25 is my pivot element, and in this indexes I need to identify which position or which index 25 will be placed after sorting. So in iteration 1 we are going to identify that particular index. Now what we need to do here is we need to increment I until the content at the index I, that is the element at index I, is less than our pivot element. So we can see here our pivot element is 25 and our next element is 67. So first I have incremented here, after which I have seen that array 1, that is 67, is less than 25. Is it true? No. 67 is less than 25 is not true. So I can just move till I equal to 1 and after that I cannot increment I. So this is about index I. Now I need to decrement my index j. Now how much I can decrement j is until my pivot element is smaller than my content at jth index. So if I check here, 11 is not greater than 25. So I cannot decrement j any further. Alright, so my j will be at 4 and my I will be at 1. Right? So what we have seen in our previous slide is if I is less than j, we need to swap between I and j. That means I need to perform a swap operation between I and j, and further my value will be 11 here and 67 here. Alright, and now again I need to proceed, and again I can check if my 23 is less than 25. Yes, so I have incremented this, right? Again my 88 is greater than 25, so once again I can increment the value of I. Now what is the value of j? J was 4. Now again we will be checking if we can decrement j any. So right now 67 is pointed by j and it is greater than 25. So yes, I can decrement the value of j. Again 88, it is also greater than 25. So furthermore, I can decrement the value of j. So ultimately where my j value stops is here. J is equal to 2. Here when we check, 23 is not greater than 25. So I can't move my j value any further. Alright, and I value is here, I equal to 3, and we have got our j value. Now what was the condition there was? We had seen two conditions were there. If I is less than j, we performed swap between I and j in my partition algorithm. In the second case, that is now in this step we can see that I is greater than j. That means I less than j is false. So finally we have got our mid value. Okay, the variable value that should be assigned to mid is 2. That means the index location at which my pivot value has to be placed is now j equal to 2. So ultimately we will swap between this pivot value and this value at j equal to 2 to see our output of the first iteration. See, so finally 25 is placed at its proper index. That means every element to the left is smaller and every element to the right is greater to 25. So it will not be sorted order, but anyways to the left the values will be smaller and to the right the values will be greater. So this is what we have got after iteration 1. We can see that the left of the partition is smaller than the index of pivot and to the right of the partition is greater than the value of pivot. So this step will be recursively applied to the left side, that is between 23 and 11, and also 88 and 77 values. We will apply these steps incrementally, that is recursively, and finally after the final increment we will get a sorted array. Now moving on to the next slide. We need to check on the left side of the pivot that we have found in the iteration number 1. That is, we will be executing this step. We have identified this mid value, that was 2. Now I will start my quicksort starting from the array from 0 to 2 only. That means the left side of the array. Now after that I will be performing, after I have completed the sorting of the left side, perform the sorting from the index mid plus 1, that is 3 to 4. That is the right side of the pivot value. Okay. Now in my second iteration, this is my array that is here. After the first iteration, Now my pivot element is again my first element, that is 23. Now I will have to perform my sorting from 0 to 2. Alright, so initially my I value is 0. Again check the condition, 11 is less than 23, true, increment I. Then J value is 23 smaller than 25, yes, so decrement J. So ultimately my I and J values are fixed at 1, right? That means my increment of I will be stopped here because next element is greater than 23, so I can't increment my value of I, but this J value will be decremented once. That means J value and I value is equal to 1. So ultimately at this condition we can see that I less than J is false. So whenever you see I less than J is false, fix the value of J and swap between the pivot value and J value. Okay, so ultimately we will get the array like this. 23 and 25 are in the correct location, and towards the left side is 11 now. You can see here that we are not checking to the right side of this array, right? After the mid value, we are not checking the right side. We will be doing it in the further iterations. Okay, so here we are only checking for the left sides. Now in iteration number 3, my pivot element is again 11. It's the only element now remaining in the current iteration, that is left side. So I will be 0. Then we can we increment I? No, right? Because if we are starting I equal to 0, we can see 23 is greater. So we cannot increment I. Start with J equal to 23. That is J equal to 1. Can I decrement J? Yes, I can decrement J because 23 is greater than 11. So I can decrement J for once. And I can see that I and J are same values. So that is the pivot value. And J value is also 0. So no need to swap and we can proceed. And finally, we can see that our sorted array is this. So the left side up to the mid value I have sorted my array. 11, 23 and 25 are placed in the sorted order. Now remaining from the iteration 1, we need to go to the right side of that particular iteration. So mid value was 2. Towards the left of mid value I have completed. Now I need to go to the right side of the mid value. Okay. So left side of the sorting is completed till iteration 3. Now we need to sort the right side of the pivot that we have identified in iteration 1. Alright. So in my iteration 4, my I value will be equal to 3 and J will be 4. And my pivot element will not be this first element. It will be first element on my right side, that is 88. Now we need to increment I until array of I is less than pivot, that is 67 less than pivot? Yes. So increment I. Now can I decrement J? No, because pivot is not less than array of J, that is 88 is not less than 67. So I cannot decrement the J value. So ultimately I will be 4 and J will also be 4. So finally I have got my J index here as 4, and now I can swap between the index of pivot and J value. Alright, so finally I will place my 88 to the index number 4. Alright, now the only element remaining to be sorted is 67. We can see here that the array is sorted. The computer algorithm will perform all the iterations before it can stop. Alright, so the next iteration will also be performed. So what is my next iteration is, I will be choosing my pivot element 67 and we will be incrementing I and decrementing J. So is it possible? Yes. I is equal to 3 and J is equal to 4. So ultimately I cannot increment I because 88 is greater than 67. So I cannot increment I and I will be equal to 3. But J can be decremented, yes. So from 4, J is decremented to 67. because pivot is smaller than array of j, that is 67 is smaller than j, so I can decrement j, and finally I is equal to j, that is I less than j condition is false, right? I less than j condition is false, and finally I have got my index value for value 67. That is finally my array is this. My sorted array is 11, 23, 25, 67 and 88. So I have got it in the sorted order. So ultimately in my quicksort algorithm, I have previously completed sorting of the left side. Now ultimately after sorting 88 and 67, this portion is also completed. Alright, so initially we will pass the entire array for sorting. After that we will give the left side to be sorted, and after that we will put the right side for sorting operation. So this is how our quicksort algorithm works based on divide and conquer strategy. So for another video on data structures, see you in our next video. Thank you all. Thank you for joining.